Press classwork. Topic 6, nonparametric test. Material, handouts, press the link, opening. This is the topic 6 handouts. What is a parametric test? What is a non-parametric test? You must know all clearly. After that, you have to remember all 4 tests. Number 1, sign test. 2, Mann-Whitney-Wilcoxon rank sum test. 3, Kruskal-Wallis test for analysis of variance or Kruskal-Wallis ANOVA. Now, Spearman's rank order correlation test for paired samples, 2 dependent samples. Ordinal level measurements. This test uses only ordinal measurement. If the original data are interval or ratio level, then we have to change to ordinal level ranks 1 to n, 1 to n after that process. If the data are not ranked at interval level but not normally distributed, then give ranks to data in each sample separately. Separately is important, not like Kruskal-Wallis ANOVA, not like Wilcoxon test. We have to do ranking 2 times, 1 to n in sample 1, after that 1 to n again in sample 2, like this 2 times. Ranking in 2 samples must be consistent. So what is this? Consistent means usually if you rank one sample from smallest to largest 1 to n, then you should rank another sample also from smallest value to largest value, that like this. And you must know how to interpret correctly. Spearman's correlation coefficient R sub S. Pearson R, Spearman RS. RS is given by this formula. This formula is not programmed, not installed in the calculators. Therefore, we have to compute by this formula ourselves. After that, the test process is all the same like Pearson's. HOH is the same, critical value reading all the same, test statistic computation, converting RS to T, the same formula. That's it. This is therefore analog to the test of significance of Pearson's coefficient of correlation. Interpretations are the same as Pearson. That is, Pearson rho or R, Spearman's rho S or RS, they are real numbers between -1 and +1, and interpretations near to 0 means weak relationship, far from 0, close to -1 or +1 means strong correlation, like this. Now let's go to example. So this is on page number 7, problem 21. Let's read. A series of questions on sports and world events was asked of a randomly selected group of male senior citizens. Senior citizens are old people, retired people. So, a test on 2 subjects was held on those senior citizens. One subject is sports, another subject is event. Some questions are asked. Therefore, these are 2 examinations. The results were translated into a knowledge score. Knowledge score is like subject scores, statistics subject score, world civilization subject score, English 2 subject score, like this. Scores are interval measurement. Given in the following table, determine at the 0.05 significance level. Symbolically, alpha is equal to 0.05. whether, okay, what hypothesis do we have to consider? There is a direct association. Direct association means direct relationship. Direct relationship means if one variable is increasing, another variable is also increasing for numeric variables. Between knowledge of sports, this is one variable, and knowledge of world events, another variable. Two variables. Of senior citizens, cases are senior citizens, subjects are senior citizens. In this study, one case is one senior citizen. For each case, they recorded world event score and sports score. Use a non-parametric test. Okay. Actually, the given table has only two rows, sports row and world event score. They are scores. Citizen number 1. Citizen row is only for matching, not for data analysis. Citizen number 1 received sports score 47 and world event score 49. The scores are very close. Citizen number 2, 12 and 10 are low score, low score. So low score, low score, high score, high score means direct correlation. So citizen number 1 and 2 show some evidence for the HA. What is HA? There is a direct association. Okay. Citizen number 3, 62 and 76, higher score, higher score. Citizen number 4, 81 in sports and 92 in world events, high score in both subjects. So on. Okay, now you are given a pair of samples, two dependent samples, numeric level, ordinal or interval or ratio. After that, you want to test relationship. So only two choices, Spearman and Pearson. Use a non-parametric test, that means Spearman. So now you can understand analysis of the problem, selecting appropriate test, why we choose Spearman, and prepare everything for the testing process. So you can understand names of the variables, sports score, world event score, level of measurement interval given, sample type dependent or best sample, test question. How shall we test statistically? Original question is dependent or independent, level of measurement numeric, sample type dependent samples, okay, parametric or non-parametric, non-parametric. So we have only one choice, Spearman's rank order correlation test. After that, you can see relationship between two interval variables, actually ordinal, interval, ratio, whatever. With two dependent samples are given. Then you have two choices. Pearson is called parametric test. Spearman test is non-parametric test. We denote Pearson correlation coefficient by R for samples, rho for population. Spearman's correlation by RS for sample, rho S for the population. Interpretation are the same. I said this. See in notes 1, that means topic 1 notes. The tests are the same. So in summary, you test rho S against 0, and you use T distribution, degrees of freedom n-2, n is the number of pairs of data. So you can recall problem 1 in topic 1 and questions 9 to 11. How to compute, how to interpret, how to test. Okay, computing the value of RS, we have to compute first. We must rank separately. After that, rank difference D for difference. After the RS formula 5 you use. Okay, let's rank sports score. Sports scores, 14 scores, from left to right, 47, 12, 62, 81, 90, 35, 61, and so on. What is the smallest? In sports row, 12 is number 1, rank 1, here, rank 1. The next one is 16, rank 2. The next one in sports scores is 35, rank 3, and so on. Go on. Finally, the highest spot score is 90, rank 14. Finish. We ranked spot scores. We give ranks 1 to 14 to spot scores. We will use only 1 to 14. So the top row shows ranks of spot score. New data. Next, wall event score 49 from left to right, 49, 10, 76, 92. Okay, what is the smallest one? 10. Now citizen number 2 got wall event score 10, lowest. Number 1 here, you write rank 1. After that, wall event score, the second smallest, what is 18, number 2. After that, number 3 smallest, which one? 42 marks, this is rank 3, and so on. Finally, 92 marks, wall event score, 92 marks or 92 points is the highest rank, 14. Okay, after that, you must give the same rank 2 times, right? Therefore, for instance, in wall event score 75, you see 2 times, they occupy ranks 9 and 10, but they must have the same rank. Therefore, you must give 2 75s mean rank, yeah, of 9 and 10. 9 by 5. 9 by 5 each. After that, 61, you see 3 times, yeah, they occupy ranks 6, 7, and 8. Yeah? So 7, 7, 7 each, 7 is their mean. And so on. After that, you see 86 2 times. They occupy ranks 12 and 13. You must give 12.5 each, the mean rank. Finish. After that, for each citizen, you find rank difference of 2 subjects. Citizen number 1, rank 5 for sports, rank 4 for all events, rank difference 1. Citizen number 2, sports rank 1, all event rank 1. Rank difference 0. Citizen number 3, rank 10, rank 11, rank difference 1. 1 or minus 1 the same, because later we will take square. Therefore, if you write negative 1, no effect. So for simplicity, you take only positive. You write only positive. Citizen number 4, rank 12, rank 14. So rank difference is 2, and so on, so on, so on. You know? So finish. Now you get rank difference D variable. 1 from left to right, 1, 0, 1, 2, 1.5, 0, 2, 1.5, 5.5, and so on. Then sigma D square you must compute in formula 5. Yeah, in formula 5, you know n. What is n? 14. Yeah, 14 cases, 14 senior citizens, n is 14. So in formula 5, you need sigma d square. Sigma is the sum, d is rank difference, square is square. So this is the sum of squares of rank differences. Therefore, the last row, 1 square plus 0 square, I left 0 square, 0 square, 0. Plus 1 square plus 2 square plus 1/5 square plus 0 square plus 2 square plus 1/5 square plus 5/5 square plus 3 square plus 11 square plus 7/5 square plus 1 square plus 1 equal to, here you get 233. In calculator, you just enter like this, 1 square plus 1 square plus 2 square plus, and so on. If the sum is very long and if the calculator stops somewhere, then you can cut somewhere, equal to, after that, plus next 1 square, next 1 square, next 1 square, plus next square, equal to, after that, go on, next square, plus next square, plus next square, plus, equal to, you can go this way. Now, HO, yeah, if you remember Pearson test, Pearson road test, you can write the same HO, HA, but you must not forget S, substrate S for Spearman. Okay? The problem asks to test direct relationship exists or not. Direct relationship exists. Row S is positive, HA. Row S is not positive, yeah, HO. After the critical value, you use t distribution n minus 2. So you go to t distribution, degrees of freedom n minus 2, like this. We can go to t table. Let's go backward. Okay, general formulas and tables, press. Then 1, 2, 3, ZT table, press the link. Okay, address, T table, alpha is 0.05, 1 till, therefore from a second column, degrees of freedom n minus 2, so 12, row 12, you get 1.782. Yeah, right till test is positive 1.872. Yeah, you see this. Go back, and topic says material, handout link, address. Okay, go on. Where? Page number 7, right? Okay, therefore we write 1.782, critical value is. Test statistic computing. Here you copy formula 5, RS is equal to 1 minus 6 times sigma d squared divided by n times n squared minus 1. So end up values 1 minus 6 times sigma d squared is 233, n is 14, enter. After that, compute all in calculator. I show on the right. Press in calculator 1 minus 6 times 233 divided by, open bracket, here I left one bracket, divided by 14 times, open bracket again, 14 square minus 1, close bracket. You need one more close bracket here, I forgot. After that, equal to, then you enter the whole formula and press equal to. You can take 4 decimals at least. If you take 6 decimals, better, yeah? More precise. After that, write down formula 6, enter 0.4879, 4-digit number or 6-digit number. After that, square root of 14 minus 2, and it's 1 minus, again, 0.4879 squared. If RS is negative, you must put the whole negative inside square bracket. Don't forget this. Otherwise, you will get it wrong. So after that, take 3 decimals. Yeah, because T table gives only 3 decimals. Therefore, if you compute the statistic, 3 decimals is enough. Round off correctly. Okay, how to compute? I show how to compute by calculator. On the right of arrow, 0.4879 times square root of 14 minus 2 is 12. Yeah? Oh, the whole bracket. Yeah, you write the denominator in the whole bracket. 1 minus 0.4879 square. If RS is negative, you must put the whole negative inside and square. Therefore, the same. Yeah? Negative square or positive square is positive. So minus positive is minus. So take care about computation. Here you can make mistake. If you write 1 plus 0.4879 square, then false. Yeah? Okay, now you get that statistic 1.936. Your test is right tilt. Yeah, HA, yeah. Row S is positive, on the right of 0, right tilt test. Therefore, the rejection region is on the right of critical value, 1.8782. Your test statistic in the rejection region, on the right of critical value. Therefore, you reject HO. Now you write correctly, formally. The null hypothesis is rejected and the conclusion would be that. So you reject HO, that means HO is false, H is true for you. So the conclusion must be that HA is true. Then how do we write? There is a significant positive correlation, rank correlation, you can write. Yeah? Or if you answer the original question, there is a direct association, yeah, HA, between X and Y. What are X and Y? Knowledge of sports and knowledge of world events. Yeah, so you write completely like this. Okay, now let's move to problem 22. This is set up a reading. If you understand problem 21 completely, then 22 is only to have experience about which number you can find where, which table, what place, only this. Professor Bud Foreman believed the students who completed examination in the shortest time received the highest grades, and those who had the longest time to complete them received the lowest grades. To verify his suspicion, he assigned the rank to the order of finish. Order of finish means who have finished exam first, who finished second, who finished third, like this. He didn't record how long, how much time each student take. He just recorded only the order of finish. After that, then grades, the examinations. The set results were shown below. So grades, there are two variables: order of finish, rank, ordinary measurement, grade, interval measurement. One variable is ordinary, another is interval. Therefore, you cannot use parametric test because one variable is lower level measurement. Okay, I give set command for you. If you want to run some data set by yourself, you can give command like this. After you have to understand the output. The output is very simple. Like Spearman. Here you see only the correlation analysis. After the inside, the title is Spearman. Spearman is written. Correlation coefficients. Coefficients for more than two variables. Now we have only two variables. There is only one coefficient. N is 12. N is 12. 12 pairs. Prop greater than modulus are under HO. Rho is 0. Rho is 0. Two-tilt test. For the two-tilt test, for a two-tilt test, probability greater than R or less than negative R, like this, is given. Yeah? The p-value for a two-tilt test is given. So if you do a two-tilt test, the p-value given is your p-value. If you are doing one-tilt test, the given your p-value will be half of the given p-value, because this table gives only for two-tilt test. Okay, let's see. Order variable. One row is titles, order, and one column is titles, order. Okay, second row is labeled score. The second column is also labeled score. So order column, order row, score column. You see the first value, the number at the above is negative 0.78809. You can also read it in score row, order column. Second row, first column, also the same number. Okay, in each box, the second number is 0.0023. This is p-value, two-tilt p-value. 0.0023, two-tilt p-value. Yeah, p-value is very small. If very small, HA is significant. Yeah. At the 0.05 significance level, can Professor Foreman conclude that there is an inverse association? Inverse association means if a student finish early, then he get high score. Order of finish number is small, the grade he received is large. That means smart students finish the exam early. Okay, his assumption is like that. Inverse association. Rho S is negative. We have to formulate this way. between the order of finish X and the test score Y, H1, H2. Name of the test source, note completely. Spearman's rank order correlation test. Spearman did it, and the test is it tests correlation, and the technique is ranking. 2. Name of the analysis variable. Analysis variables, the variables we analyze, order and score, both the same level. HA first. Question 4. Inverse association means row S is negative, HA. Therefore, HO not negative, greater than or equal to 0. Your test is 1 tail test, therefore p value is 1 tail. The given p value is 2 tail, therefore divide by 2. Your p value is 0.00105. Now you know how to decide. P value is smaller than alpha, you reject HO, right, formally. The null hypothesis is rejected, and the conclusion would be that. Okay, what do you write? You reject HO, that means HO is false. That means HA is true. You must write in conclusion that HA is true. So you write copy the original question. There is an inverse association between the order of finish and the test score. That's finished. Okay, critical value reading. You can check. You go to T table, alpha 0.05, row 10, because n is 12. N minus 2, row 10. If you go there and read, you will see 1.812. But your test is left tail test. 22.4 HA. Row S is less than 0. Row S is on the left of 0 on the real number line. This is called a left tail test. Therefore, you write negative critical value, negative 1.812. Test statistic. You can use formula 6. Enter negative 0.78809 in place of R. You can, right. Okay, 45. You compute and you will see negative 4.047 if you round off to the third decimal.